let us discuss how can we create logics using transistor. So we know the transistor can work as a switch. If we apply enough voltage here to the base, we can turn this transistor into the saturation region such that the VC will be zero. Similarly, if here base voltage is zero, no current will be flowing here, IC. So all the voltage applied can get drop across the VC. So using these two operation or two concepts, we can create different kind of logic gates. Let us understand one by one. So for example, if I want to create an AND gate, so the output of AND gate is high only when both the inputs are high. If any one input is low, the output will be also low. So let us discuss using this function using transistor. So now if I apply A0 B0, this base is zero. So once this base is zero, obviously base current is zero, no IC will be flowing or negligible IC will be flowing, only reverse saturation current may flow. So if no IC flowing here, this is base, no IC flowing here, so IE also will be zero. That means you will get a zero output here. Okay, now let us understand the second case. If I apply A0 B1, okay, in this case also, if B is 1, B is 1, A is 0, A is 0, if A is 0, that means IC is not flowing. So if IE of this transistor is not flowing, that means IC of second is not flowing. So obviously here ammeter current cannot come. So ammeter current cannot come, or there is a negligible ammeter current used due to reverse saturation current. So again, the output here also will be 0. Okay, similarly, we can see a third case. If this is 1, okay, if this is a 1 and this is 0, if this is 0, again this IC cannot flow because base current is 0, so it cannot derive to the transistor in the active region. Okay, again here will be negligible ammeter current, so here voltage drop will be almost 0. Now if both are 1, then here ammeter current is flowing and this become IC collector current for second. This is also forward bias, so current will be flowing here. Okay, and you get high output. So in this way we can implement AND gate using two transistors in series. Okay, let us understand now how can we create a OR gate. So if I want to create OR gate, we have to connect transistor in parallel. So now if both are 0, okay, if both are 0, obviously that means current cannot flow in this resistor, so you'll get the 0 output. Okay, now any one of is 1. Okay, suppose A is 0, B is 1. So if B is 1, then this is conducting, so IC can flow here, ammeter current can flow here, so you get high output. Okay, if this is 0, this can conduct. Okay, IC can conduct here, IB is flowing, IC can flow, similarly IE can flow, and IE can come here. Again, you get high output. Similarly, both are high. Okay, so when these both are high, no voltage drop will be across VCE, because this is high enough to make transistor go into the saturation. So the voltage drop across VCE will be 0. Okay, and so all the output, this output, okay, will create current, and this full voltage will come almost 6 volt will come here. Okay, so this is high will give you high. So this is your OR gate implementation using a transistor. Okay, similarly we can create say NAND gate. Okay, NAND gate circuit is same like your AND gate, only instead of taking output at the bottom part, we are taking output now at the top part. Okay, again, if both are, if these bases are at 0 volts, not conducting, so current cannot flow here. If current flow here, so all the voltage will come to the output, no drop here, so this output will automatically come here. Okay, so NAND gate is just opposite to AND gate, so you get low input only when both are high. So suppose any of one is any one of is conducting. Okay, so this is 1, this is 0. So this is 0, so this current cannot flow, so this will come here. Say this is 1 and this is 0. Now still again this current cannot flow, because here here for this transistor, IC cannot flow. That means IE cannot flow. So IE cannot flow. That means IC, this current cannot flow. So here this current cannot flow. So there is no drop. So this 6 volt automatically come here out to the output. Okay. So this way we can create NAND gate. Now let us see the final 1 1 1. If this is 1, this is 1. Okay. Then current will flow here. This 6 volt will get drop here, and here you'll get here at the VC you'll get the negligible voltage. Okay, so we can generate this table and this entry of this table. So the last you have a NOR gate. NOR gate, again the circuit is same like OR gate, only we are taking output at the top. Again, NOR is opposite to the OR gate. You get high only when both entries are 0. So if both entries are 0, no current will flow here, and this voltage will come exactly here without drop. Will come here. You get high. If anyone is base conducting, so the current flow, suppose this is conducting, so then this current will come here, IC will flow and go to here, so you get 0 volts here, so all the drop will be here. Similarly, if this conducting, again current flow and the here will be drop and you get 0 here. Okay, so this way also we can create NOR gate. There is a one more alternate way to create NOR gate by putting two resistors into the base. Now, if both are 0, this is not conducting. If this is not conducting, no current is flowing. This coming directly here, so you get the high here. For 0 0, you get high here. If anyone is high here, then the current is flowing here. Current is flowing means here all the drop is here. You get output 0. Okay, so this way we can also create a NOR gate using using alternative way. So this is this use of transistor as a switch and as a switch. Okay, we can implement all the logic gates for transistor family. Thank you very much.